Hello, everybody, and welcome to an introduction to SQL injection. For the purpose of this demonstration, I shall first start explaining the network configuration pertaining to this demonstration. We have our host system residing at this IP address, 192.168.21. Then we have our victim computer, which is running IIS 7 on Windows 7 and Microsoft SQL Server 2008. And then we have our Kali Linux attack machine, which resides at the following IP address, 192.168.2102. This configuration was set up using VirtualBox. We have a VirtualBox host-only adapter configuration with the 255.255.255.0 as the subnet mask and no DHCP. So without further ado, let's start. We shall talk about this app right here, which is Book Service. This is going to be a very quick tutorial. So first and foremost, we're going to choose the name of any book. For instance, we're choosing a book where we have ID equals 3, and we're having the book details in here. Traditionally, SQL injection is being checked by appending a quotation mark in the end of the integer. And this right here provides us with an error page. Now, bear in mind that not all applications are going to be as verbose as this right here, where we obtain a bunch of information. But for instance, we know it's ASP.NET. We are being offered some directory structure information, which of course could come very useful to an attacker along the way. Now, one way of checking whether an application is vulnerable, for instance, the integer 3, it's also 9 minus 6, for instance. And in this case, as you could see, the page executes and it provides us back with the result, which would have been displayed if ID would have been equal to 3. This is also a very effective way to bypass the web application firewall and the IDS. I have prepared here a file with commands which will aid us in our demonstration. And the first one would be, let's suppose that I want to enumerate the database name. I'm going to type in this command right here, which it's going to give us the name of the database because we have a conversion failed when converting the nvarchar value book app to data type int. This is an overloaded SQL Server function which takes as a parameter an integer, an array type integer. So for instance, if we type 0, we get that error. If we don't type 0, by default, it's the same. But now, for instance, if we were to type 1, then we get the second value, the second database name in the system. If we were to type 2, we'll get the third database name in the system, and so on and so forth. For instance, suppose I want to download or to view actually the first table in the database. Then I would type in this command right here, which is very basic. So we have the ID equals 2 or ID equals 4 or whatever, doesn't really matter, or 1. So this evaluates algebraically to true, 2 or 1. In select top 1, name from system objects where hex type equals char 85, which is a type U. And we get the name of the first table in our database, which is called bookmaster. The type of injections we've been dealing with so far in this very short demo have been error-based injection, where we have been able to infer data from the error which was presented to us, or in this case, union-based injection, in which we are appending queries to a parameter. We are joining queries. Another useful injection, for instance, if I want to see how many columns are in a table, I might type in something of this nature, and I get an error. It says the order by position number 40 is out of range. So, of course, if 40 is not available, then who's available? Do you have 20 columns? No, 20 is too big. Now, do you have 10 columns? No, 20 is too big. Do you have 5 columns? And the database says maybe. So usually what we do, we look for the biggest number underneath the number which is the greatest. So for instance, our greatest number was 10. So let's try it with 9. 9 also satisfies the database. Hence, we know that this table has 9 fields. Now, we have to decide which fields are exploitable. And in order to do that, we shall pass in the following query. And we paste it in. And as you could see, field number 7, 2, 3 and 4 are fields within the table which enable an attacker to extract data out of the application. For instance, I prepared a query over here where in the second field, I'm typing in user, in the third field version, in the fourth field server name, and then in the seventh field, I'm extracting the password hash from the database, which of course we could later decode if we have the time. As you could see, this is the password hash was displayed in field number 7. Then we have the name of the database, which is DBO, the username of the database. And then we have the SQL Server 2008 Service Pack 3 running on that platform. And then we got the name of the computer, which of course, for the purpose of this demonstration, I downloaded this from Microsoft in order to demonstrate the basics, the very basics of SQL injection. We also have something very interesting called time-based SQL injection or blind-based SQL injection, where once again, if the application is not as verbose with us, then we're basically going to use a time wait function. So basically what we are saying here, we're saying, well, if the system user is different than SAPS, for instance, in this case, as you see, I just made up a user, SAPS, then wait for a delay for 10 seconds before displaying the page. In this case, the system user does happen to be SA, which is the default abbreviated credential for Microsoft, which is System Administrator. Hence, if we are correct, this page should take 10 seconds to load. And as you could see, it's loading. The reason for which it's loading is because the username is different than SAPS. Of course, if we were to type in the true username, then it wouldn't wait for 10 seconds because the condition would evaluate to false. As you could see, that's the case. Another thing we could do, we could try to execute a command. In this case, I'm going to execute ipconfig via the command shell, which is sometimes enabled by default. And it seems that the command was executed, but we don't see the output. So in order to properly see the output, we have to type in something along these lines. And in this case, we're directing the output to the directory. Now, how do we know this directory? From the previous error. So now, since the text file appears to have been created without an error, we should be capable of viewing it in the browser by typing the whole URL and then test1. And here we have it. So that was successful as well. Now, another thing, another way of interacting with this application, this was the basic of SQL injection, of course, we could go into the login screen, and what's traditionally done in the context of SQL injection is trying to log in with a string along the following lines, something equivalent to this. And we're going to see why it works in a second. So we are being logged in as the first user, Mike. Now, why does it work? I'm not sure this text file is big enough. But anyway, the reason for which it works, it's because it's a select ID from users where username equals the username from the web app and password equals password. So these are unprepared statements. And basically, whenever we type in the query above, which we typed, then we are just closing the username, and then we have an or 2 equals 2. That's why we left the 2 unclosed previously. And we have the password equals whatever, or 2 equals 2, which always evaluates to true. Hence, we've been able to see how to log in as the user Mike. Now, for our next step, we are going to use a tool in Kali Linux, which it's called SQL Map, which is a pretty useful tool, though it only checks for blind injection and union-based, so it does not do time-based attacks or blind injection. And in order to use SQL Map is pretty much self-explanatory from its own menu. Nonetheless, I prepared a command which is going to dump the whole database, and another one which is going to pop a shell. But the first one, for instance, would be this. And as you could see, the whole database was downloaded into bookmaster CSV, computer separated, comma separated values. And as you could see, this is the content. It makes no sense whatsoever to go and actually view it because you could try this yourself. I mean, it's pretty much self-explanatory. Another cool feature of SQL Map, as I previously mentioned, it's popping a shell. Though this service tends to be discovered by the web application firewall, there are more sophisticated methods of obfuscation. But for those, that's in another course, in a paid course. So now it's running. I just realized I typed in the wrong IP address. So let's see, it was not 2012, it was 2100. Anyway, so we got our shell. So in our shell, and of course, we are being presented with the Windows operating system version or a guess that matches the signature. So now, for instance, I could execute any type of commands pertaining to a Windows operating system, such as ipconfig. And as you could see, I get the output as if I would be running directly on the Windows box. I don't know if this is visible or not. I guess so. For instance, if I type in net view, net users, or whatever, let's see what that will give us. So we're seeing the computer name and the server name. So this was a quick introduction to SQL Map. Now for the next step in this demonstration, we shall actually see how we could display data on the fly and execute data. But before we do that, another feature that takes place in a lot of the web apps, it's remote command execution. So for instance, if I were to make up anything right here to subscribe to the newsletter, like let's say that at yahoo.com, if the developer does happen to write the email address in a database via some code execution, then we could just append the ampersand string and execute a command. So in this case, I'm just going to execute a dir, a very basic command, doesn't really matter, and redirect the output to C inetpub, whatever, which I just, I think I wrote right here. So in this case, I had ipconfig, so let's just do ipconfig. It doesn't really matter. It's the same thing. So let's see if we subscribe. It seems to have worked. So if I would type in test2, then it would seem that once again we're being able to view command execution and on the remote system. There are ways, of course, the natural question presents itself, does this really work in real-time scenarios? And the answer is yes, it does. For the next part of the demonstration, we are going to use burp suite in order to gain a further understanding on the behavior of this app. And I have the free edition of burp suite somewhere around here. Let's see where it's at. Burp suits, there you go. This is the free edition. We have to set it up as a proxy on port 8080. What I wanted to show you in this app, for instance, first I gotta reload the page for the proxy to accept the connection. So resend the info, and now we go to proxy. The request got intercepted, and we forward the request. And we forward the request again and again. And of course, okay, we are in a mic. Now if at mic I go in a profile, and inside profile I want to view the newsletter. And then I click on the date of the newsletter. Bear in mind, pay attention that when this is displayed, This application happens to suffer from a local file inclusion. So basically, it's asking for to view a text file which is stored on the C drive. Just forward it, and let's see what happens. So it's getting this display. So probably that text file, most likely it's on the C drive. Now, do recall that we know quite a few things about the structure. So if I am to open up another window with this right here, and then with the ID name, so we're going we're gonna go here. And now let's see, let's view a book. And now let's cause an error again. And now let's take a peek at the source code. So how do we take a peek at the source code? This is in C sharp. Just copy this right here, and then we go back here. And then whenever we try to reload the page, we click on send. We trap the request, and instead of this right here, instead of asking for the original newsletter, we just ask for the source code, and let's see whether this works. It should work. Let's see. And voila, we got the source code in C sharp of the book app. Okay, so this was a very quick demo about local file inclusion. There's something else that we need to test for, which is very popular with the web apps, and that's cross-site scripting. And cross-site scripting usually, as a rule of thumb, takes place whenever user input is being reflected somehow on the user interface. So first, let me stop burp suit because we don't need it anymore. And let me take it off. And now we're on again. So for instance, let me log out Mike because we don't need Mike anymore. Let's suppose I type in, of course, I had time to play with this application. Whenever you do pen testing, you have to know the app in and out pretty much. But nonetheless, for instance, like let's suppose in Go, I type in a random string and then I click Go. It says no match found for whatever random garbage string I type. So there seems to be an indication that some sort of an input is being reflected back to me. So what if I try for the garden variety alert script? So I type alert, it seems that it does work. So now for the last part of this demonstration, we're going to use something called Beef. Beef is just browser exploitation framework. It's a very powerful tool. I myself often use a proprietary written tool which I have developed for man-in-the-middle attacks, which is very similar to Beef, but nonetheless probably a bit more powerful and a bit more devastating. We type in the username and the password for Beef, which by default it's Beef and Beef. And now we're going to go here, and what we're going to do, the way Beef works is the following, right? If cross-site scripting is permitted, and in this case it is, as we found out, then what we are going to do, we're going to include a JavaScript which is going to ask for the IP address of our Kali machine, which, as if you do recall, resides right here. And we're going to try to see if we could hook it up with Beef. Now, the request string in this case is this because our browser otherwise would detect our cross-site scripting. So we type in that. There's no match for the greater than sign. But nonetheless, why am I typing this up? It's just a trick which is somehow used in order to bypass for cross-site scripting, because modern browsers nowadays, they would detect it right off the bat. Probably the worst browser, it's Internet Explorer, which can be commonly found in a bunch of organizations, and it has to be used as per company policy. In any event, it seems that our request was successful, and as you could see, I performed this test before, of course, and this was an offline browser, but we got an online browser right now, and the online browser, as you could see, comes from our 20.1 machine, which is the machine from which I'm performing the test, is this machine right here, ipconfig, and it's on the 20.1 VirtualBox, this one right here. Nonetheless, the beef exploitation frameworks could be used in various ways. Now, once again, this is a introductory tutorial, so I'm only gonna show you one such exploit, social engineering. My favorite exploits are probably are social engineering exploits due to the fact they're probably the most powerful. So a bit of word about this right here. Basically, the IP address right here could be 192.168.20.102, the address of our Kali machine. And then in the demos folder, I should put in a spoof page with Google. We're not going to do that for the purpose of this demonstration. I am too lazy right now and for the brevity of the video. But nonetheless, if we do execute the command, we see that there's a command executed. Of course, there's nothing yet trapped from the command results in the panel. But if you take a look right here, you got a Google page which just popped out of nowhere. I guess nobody's thinking this is a real Google page because it's not. If I type in anything, you could see it's going to probably take these credentials to this right here, which is the IP address which you haven't set up. Well, this is the end of this free demonstration. For advanced SQL injection and for advanced OWASP techniques, please do not hesitate to contact us, and we'll get in contact with you as soon as possible. Thank you.